Can everybody hear me? Awesome. All right, thanks for coming back for a second round if you were here yesterday, or for sticking it out till the end of day 2 of SEO. I'm here today to talk to you about Thunderdome and what we've accomplished over the last year, and kind of what lies ahead of our schedule for the next foreseeable future. So in case you've never heard about Thunderdome before, we started undertaking this OTA for a prototype-driven pilot last year, probably around the same time as this. And we had a couple of goals in mind. And so we got a lot of questions about whether Thunderdome was going to be a full zero-trust implementation, and the cheap answer is no, it's not. But we kind of had this realization that both from a performance perspective and from a security perspective, and with a presidential memo in mind that compels everyone to adopt zero trust, it was probably time to think about modernization of our network. And so the easiest way that we could envision doing that was through bite-sized chunks. And so we focused on a couple of transformative technologies that we thought kind of lay the foundation of everything that DISA will need to implement on their zero trust journey going forward. And so we awarded this OTA for originally a 6-month prototype, and then extended it a couple of times to accommodate additional scope of work. And what came out of this, we'll look at in a minute in terms of the work streams that we were working on. The idea behind this was to develop operational experience, so we didn't want to just implement a couple of technologies in the lab and see how that goes, but we actually wanted them deployed on our operational Nipper network, with actual DISA users accomplishing their daily work on that prototype. And we accomplished that for about 1,500 users across 3 DISA sites. So we implemented at DISA headquarters in Fort Meade, at DISA PAC in Hawaii, and then we also had some users that were supporting a JSP at the Pentagon. In addition to that, at some point Army approached us with a prototype that they were interested for a CAP alternative solution for a specific use case they had in mind. And so we were able to work with them on that use case successfully, and we're currently in the process of onboarding up to 400 additional users from the US Army in support of that remote access pilot. During the year, we also wanted to make sure that we don't just build a solution that objectively works for user access to resources, and that the technologies work, but also that they're implemented in a consistent and secure manner. And to that end, we worked with JITIC on an operational assessment, actually did 2 rounds of operational assessment, because we had a couple of capabilities that our vendors implemented throughout the OTA, that we then went back to JITIC and had them retest and kind of validate that they were meeting the requirements of our RFP. And additionally, conducted a cooperative vulnerability and pen testing engagement with the DISA Red team to ensure that we didn't just deliver a usable, but also a secure solution. As I mentioned, the Thunderdome prototype is not really intended to be our the end of our solution on the way to ZTA. We focused on a specific set of capabilities, and so roughly speaking, what we're deploying as part of Thunderdome falls into the categories of zero trust network access, cyber SA, so analytics, and into automation. And the idea was to de-emphasize perimeter-focused defense, to establish microperimeters around specific resources and applications, and to focus more on authentication of individual resource requests. So gone are the days where you get a Nipper IP address, and that kind of sends you on your merry way across our network, towards having to prove every time you want to access a resource, whether that resource is data or a system or a specific API in a capability, that your device is compliant with our security requirements, and that from a user perspective, you fall into a group and organization that is entitled to access that capability. The specific capability we implemented or the capabilities that we implemented for zero trust network access were especially interesting for us because they integrate with each other. So we can drive zero trust network access at the edge for both remote network users and on-prem network users, using a single agent, not adding to the agent load on our endpoints, and additionally impacting those systems. And it allows us to realize a couple of network optimizations in addition to providing better security. And again, we'll look at those improvements in a second here. And then the last goal was to increase automation in network and security deployment and management, which is a roundabout way of saying that now we're kind of at a point where we can consistently deploy and manage these network appliances. We're using a single network operating system that supplies both routing features and security features. And because all of the configuration is done from a central orchestrator, both for the SD-WAN deployment or for the on-prem component of our Zero Trust Network Access component and for the remote component, we don't have configuration drift anymore. And we can kind of ensure that in a shorter amount of time than it would have been possible in the days of manual configuration, we have a consistent configuration baseline across all of our devices. So here then are the components that we're deploying. The first two make up what we're calling Zero Trust Network Access. The first capability is a Sassy solution secure access service edge. And so for that, we've chosen Palo Alto's Prisma Access. And the capability replaces both our traditional remote access VPN, which for us currently at DISA is the JRSS-supplied Cisco AnyConnect solution. It allows us to apply conditional access to remote users. So for any resource request, we can now take into consideration not just the user's identity, but also the posture of the device, ranging from the operating system that they're running, so we can ensure that they're coming from a supported operating system on a managed device, and running an approved endpoint security solution that has been updated and executed recently. The attributes that we can evaluate on the endpoint are pretty numerous. And they're evaluated both at the initial sign-on and then periodically thereafter. So we kind of have an ongoing reevaluation of the security posture. The second thing that we get out of the Sassy deployment is an improvement in routing. The Sassy component is deployed in AWS GovCloud IL5. So gone are the days where a user initially has to connect through the IAP to get to our network to then be routed back out to the internet if that's where the destination they're trying to reach was ultimately hosted. The initial endpoint is at the cloud edge, so it's much closer to the user. And any anything that's directly accessible on the internet gets routed out from the Prisma Access solution to an internet-facing interface, so that only cloud and IL4 and 5 cloud-bound traffic and traditional DISA traffic have to be routed back to our enterprise network. And so you can imagine that alleviates a lot of stress on the IAP. The uptick in stress on the cap from the shift of ingress connectivity from the IAP to the cap is actually relatively minor, because during the pandemic, we've kind of taken an initiative to shift a lot of our capabilities towards the public cloud, in which case we're connecting through the DISA cap architecture today, but for anything that can be serviced by the same cap, that traffic no longer has to hit the cap security stack or be transported by the DISA for transport. So we kind of have a trifurcation of traffic. The long-term goal here is really to de-emphasize the role of the cap even further, to become primarily an interconnectivity point and to shift the security function of the cloud access point today towards edge-based solutions like our Sassy implementation. The second part here is an SD-WAN and what we call customer edge security stack, but which you also could refer to as software-defined security solution. And so for that, we've chosen a vendor called Versa that supports many carrier-grade deployments today, both in the private sector and to a lesser extent in the federal space. And that delivers edge connectivity of sites back to the DISA. So for any current JRSS customers, this will be a way, albeit not the only way, to connect back to the DISA after the JRSS sunset in FY27. And also provides a lot of the functionality that JRSS currently delivers from a security perspective in one integrated operating system. And so we've gotten a lot of questions about whether that means that we can have a single box deployed out at the edge that now does all of JRSS and all of the routing. and replaces both the big iron routers and security capabilities in a single one-use box, and obviously the answer is no. But there's a concept called service chaining, which means that we can deploy inexpensive commodity hardware and implement the functions that we need to implement in whenever we reach the resource limits of a single one of these commodity boxes. We can deploy a second box in close proximity and then kind of spread the traffic so that security functions can be carried out by one box and the routing functionality can be carried out by another. The SD-WAN solution, or the Customer Edge Security Stack solution rather, also provides conditional access for on-prem users. So again, our goal was to push security and authentication as close to the user as we possibly could. And to that end, it made sense for us to have separate policy enforcement and decision points for remote and for on-prem users. The policies in many cases differ between the remote and on-prem populations anyway. We have some capabilities to translate policies between the two capabilities, but we didn't really think that it was a big detriment to the solution to not have a single policy enforcement point that services both of those user populations. As I mentioned, one of the great integrations we were able to achieve with the help of the two vendors here for the SD-WAN and Sassy solutions was that both of these are fed by the same user agent. So we have a single piece of software deployed on user devices that collects the security posture and adds tagging of the user ID for the user to any traffic traversing them without having to add to the kind of agent load that we already have on DoD endpoints. The SD-WAN capability is an overlay from a routing perspective to the existing DISA routing, so not a whole lot changes there. If you're currently a JRSS customer, then in order to maintain connectivity back to the DISA, we'll have to replace the current circuit that you're using to connect to JRSS with a DIPper circuit. But apart from that, we can really provide the same connectivity, just now no longer concentrated at the base or regional tiers and pushed all the way out to the customer edge, so to individual sites. From a tenancy perspective, our goal is to have a three-tier hierarchy with a DoD tenant, a policy-only tenant at the very top. So for any Thunderdome customers, there will be a tenant at which we can implement cybercom policies for the first time and push those down and make them inheritable by child tenants. So if the Navy or the Army, for example, are child tenants to DoD, then they would automatically inherit these security policies from cybercom and no longer have to implement them manually. And they can be more restrictive than the parent organization, but never less restrictive. The policies coming from cybercom obviously are fairly limited, so it's not like we're pushing a lot of policy towards you here that you don't have control over. But it kind of gives an additional layer of speed in deploying what used to require a task order and for us to react to emerging threats. Under that top tier tenant, we can have two additional tiers of tenancy. Only the leaf tenant can have policy objects associated with it, so users and devices are only associated with the last tier, whether that is a second or a third tier. And we've talked to a number of services that have different approaches for that, and we happily support both to have a single agency-focused tenant or to break out by individual sub-organizations. We can support both of those. The second work stream here is what we're calling the application security stack. Again, the first work stream, those two capabilities making up zero trust network access. Application security stacks are focused on the problem that today it's very tedious for DoD capabilities to deploy security in a consistent manner. And as I mentioned, we kind of want to get away from this idea of having big perimeter defenses and then not a lot of defense after that, towards a model where individual applications and even components of those applications become more self-defensive or defensible. And so to that end, we realized that in our enterprise security architecture, in many cases, we already had a WAF and a next-gen firewall sitting in front of many of our applications. And so we looked at what we can do with that to spare DoD a large investment in additional hardware and software, and realized that we can achieve east-west inspection, so the ability to detect and avoid threats stemming from lateral movement by simply hairpinning the application internal traffic through that same security stack. So no additional deployment of capabilities needed in many cases. We're retooling what we already have in place in many cases to achieve this additional effect of restriction of lateral movement of adversary capabilities. In addition to that, we wanted to provide a solution for containerized applications, realizing that DoD is increasingly investing in re-architecture of its applications to make better use of cloud resources. And so we included a Palo Alto solution called Cloud Compute, Prisma Cloud Compute in the application security stack that provides additional provenance information and compliance information for containerized workloads. That's obviously an optional deployment piece and only applicable where we have containerized workloads, but it's really helpful in that it's orchestration agnostic, so it works for anything running in pretty much any of the big orchestration engines, whether it's AKS, EKS, OpenShift, or whatever else you've got deployed major. The application security stack isn't really intended to be a DISA managed capability necessarily, and licensing will likely have to be supplied by individual programs. There's definitely also some implementation work that has to be accomplished by the program, since we can't centrally figure out the complexity of every DoD application. But we were wondering how we can make the deployment of a security solution easier for application owners. And to achieve that, we've implemented both infrastructure as code templates to lay down this infrastructure initially for anything that's hosted in an IS environment or in VMs. And then also build configuration in Ansible around it to automate some of the initial configuration to deploy a safe baseline to these devices. The capabilities, I don't remember if I called out here, that we're using for the WAF and next-gen firewall are F5's WAF and Palo's next-gen firewall, which are both also available in physical footprints, so that we can support with the same configuration both physical and IS and VM hosted application solutions or solution architectures. The last work stream we have here is called CyberSA, and that's currently focused solely at the DISA CSSP mission. But a couple of years ago, it dawned on us that we didn't have a good solution to tie together all of the cloud-native solutions for CyberSA that were emerging in cloud service provider environments. And those solutions, for the most part, are providing great value, but they're kind of limited to a specific cloud service provider's environment. And so for our analysts, that led to either having to learn and relearn constantly different query languages and rebuilding the same dashboards in multiple cloud service provider tools, or to backhaul all of the data at great cost into a central environment and then build out analytics there once. So we were wondering how that could be done better. And the architecture we came up with revolves around federation of data. So we're looking to have a CSP agnostic architecture. We can instantiate in any cloud service provider's hosting facilities, kind of provide an overlay to the cloud native tools that the cloud service provider is providing, and then achieve federation between different CSP implementations of the CyberSA stack to expose the telemetry both of our own application stack and for Thunderdome, as well as for any cloud-hosted SaaS or IS application. As part of that deployment, we're leveraging what we're calling a smart data pipeline, which uses a Jake-developed tool called Perceptor that allows us to perform some normalization, enrichment, and tagging of data in flight before it gets exposed. And so you can imagine, currently we have analysts manually looking at reputation information about URLs manually for every investigation they perform. And so automating things like that goes a long way for our analysts and frees up a lot of time that they otherwise have to manually expend. The capability also has the ability to deploy certain levels of, or certain types of machine learning models to streaming data. As you can imagine, for streaming data, there are limitations to anything that requires a lot of lookback and large windows. That's maybe not a great candidate to be deployed here. But anything that can be used for classification of data, for example, is a great candidate to be deployed as part of that smart data pipeline. And then the actual federation and exposure of the data. We're doing through Elasticsearch today, just to have an initial way for analysts to interface with the data, to do some visualization, and then to further groom it and export it to tools that they want or need to perform the investigations in. We already kind of talked about the performance improvements here, but just as a visualization, previously we had a single data stream, and that always was routed the same way, no matter where the ultimate destination was. And so for the Sassy capability, and to a lesser extent for our SD-WAN capability, for the first time we've got the ability to provide differentiated routing based on the ultimate source and destination of the traffic, while employing the same consistent security means at the edge for that traffic. And so from a metrics perspective, we've done some investigation. Our modeling and simulation team has had some looks at how the changes in routing impact our data. And they've been very encouraging, and we've seen a pretty sharp decline in the latency of the data, and have received really great feedback on the usability of our solution from the pilot users. We're often asked what role Thunderdome really plays in Zero Trust, and everybody has a different definition of what Zero Trust means for the enterprise. So we kind of wanted to lay out what we do and don't do out of the things that we're currently that we're commonly asked about. And so endpoint security is a thing that seems like a good fit for a Zero Trust solution to provide. But we don't actually add any new endpoint security solutions. We're interfacing with any existing endpoint security solutions. So as DoD, for example, transitions from the current endpoint security suite to other solutions and to multiple approved solutions, we can integrate with that data and ascertain that they're running and that they're doing what they're supposed to do. But it doesn't really require us to deploy any new solutions to further that goal. And that's kind of, I think, the bottom line of what we're trying to do generally when it comes to integration with other tools that already exist on our network, which is to integrate with them rather than to duplicate what they're doing and field additional tools specifically for Zero Trust. Zero Trust network access we talked about both for remote and on-prem users. That is provided through our Sassy and SD-WAN and customer edge security stack solutions respectively, with enterprise ICAM as an underpinning to provide the identity data that all of this is founded upon. For any Zero Trust use case, identity kind of provides the underpinning, and if we didn't have a good identity provider to deliver attributes to make decisions based on, then the whole idea of conditional access kind of would fall apart. And so we spend a lot of time integrating with the enterprise ICAM portfolio to get that identity information and make it available for conditional access decisions. The application security stack we also already discussed, so the focus here on microperimeters around applications and making it easier to deploy a secure baseline of application protections in front of specific applications. Application conditional access might seem counterintuitive, but that is actually not a thing that we're providing for a simple reason. You can kind of think of our Ztna capabilities as a gate in front of applications, and so there are two ways to implement this. You could either require upfront integration between a Sassy solution or a policy enforcement point more generally and an application, but then you kind of have to invest a lot of work upfront for an initial implementation of that technology in front of every application you want to protect with it. The approach we've taken here is to kind of decouple the two and to install our policy enforcement point as a gate in front of the application, but without any pass-through of authorization or authentication information to that application. So from a user perspective, you get two authentication dialogues, but it enables us to implement this additional layer of security without requiring application owners to make any changes on day one, and they can then later work with us on refining conditional access policy and being more granular in the approach to how we govern access to specific interfaces of the application, but that doesn't need to be done on day one. And similarly, from an application perspective, the application in many cases has much better knowledge of its own internal roles and what roles users perform within the context of the application. So it would be really difficult for us to implement that in a generalized policy enforcement point. And so this kind of allows us to do coarse-grained, but finer-grained. Then we can provide today access control in front of the application, and then the application can independently, together with the ICANN portfolio, provide more fine-grained access control. ICAM, as I mentioned, DISA has an enterprise ICAM offering in GFAD that is heavily being leveraged for us, both for user authentication and to deliver user attributes to us. I don't want to gloss over the fact that the current ecosystem of identity attributes in DoD leaves some room for improvement, and we're working with the agencies that have an impact on that, on improving the attributes that are being shared with us. But the ICAM portfolio really presents the underpinning for everything we're doing here. So it was very important for us to integrate into that ecosystem early on. Data tagging and labeling is always an interesting discussion to be had. A lot of people think that Zero Trust kind of lives and dies with data-specific protections, and we agree that that's an important thing. But data tagging and labeling have really kind of been elusive goals for DoD for quite a while, and so we think that it's really important for us to focus on that and to make headway there, and then move into DRM and DLP, so digital rights management and data loss prevention. But we have to get the data tagging and labeling piece right first. So we're currently investigating a number of solutions that can get us started on that by using automated labeling for some easy to get after use cases. But there'll be a specific or a pretty significant investment across DoD to broadly deploy data tagging and labeling on the NIPR fabric. And then the last piece, visibility and analytics, is kind of a shared responsibility across a lot of organizations in DoD and departments in DISA. We're part of the sensing infrastructure, obviously. The solution we're fielding here emits a rich set of telemetry that can be used both internal to Thunderdome for decision making, but also externally to it for insider threat detection and a number of other use cases. But likewise, the Cloud DCO environment that we're deploying here can integrate a lot of telemetry from other components that might be useful for us to make decisions on. And so that combined output we can then expose to a source solution for automated actioning on data, both produced by our stack and by external stacks. So let's look at what we've done over the past 12 months. And I think the achievements here are pretty significant. They might not look like much for anyone that has never worked in DoD, but progress is typically slow for us, and so we're pretty excited about what we were able to do here. And it took a great team on both the government and the vendor side to make this happen. So over the past 12 months, we've integrated all of the different Thunderdome components with each other and into the DISA and in some cases DoD enterprise ecosystem. And deploying in a greenfield environment obviously is much easier than deploying in a brownfield environment. So being able to fit into an existing enterprise network and integrating with capabilities, legacy capabilities that in many cases are immutable to us was a pretty significant achievement. We were issued a full authority to operate for our capability. As I mentioned in one of the first slides, we migrated over 1,500 pilot users at 3 DISA sites to our remote access and on-prem solutions. All of those users are using one of those 2 solutions, depending on whether they're teleworking or in our office on a daily basis, and are accomplishing all of their work using our solution. And we're still in the process of expanding that user base across DISA and the different DISA field activities. We completed a cooperative vulnerability and pen testing assessment and operational assessment. We already talked about that. We actually have a follow-on action scheduled in the next couple of months to conduct an adversarial assessment, which for anyone not tracking the nuance here, the CVPA requires some level of cooperation between the red team and the program. So they're able to ask us for specific actions that they couldn't carry out on their own. And generally that tips us off to what they're doing on our network. The adversarial assessment is more black box, so we don't have any insight into what the red team performs. And likewise, we don't have to help them, so they kind of have to stand on their own field and feet and can make only the progress they can make independently. We've demonstrated conditional access for both remote and on-prem users and that integration between the two solutions. We've collaborated with mission partners to ensure alignment between the different zero trust pilots that parts of DoD are undertaking and exchanged lessons learned with those partners, not just within DoD, but also with federal mission partners. And we've had a lot of really fruitful discussions with the private sector to kind of get more insight into how they're thinking about these same problems and how they're solving them. And we've collaborated with vendors to increase performance for Oconus users. A thing that I didn't touch on initially here, but because our Sassy solution is deployed in AWS IL5, there are currently no Oconus instantiations of IL4 and 5 cloud services. We realized that the performance for Oconus users might be less optimal than for Conus users. And so we're currently working with both the cloud service providers and with our technology vendors on local instantiations in PAC and Europe. From a challenges and lessons learned perspective, I think we've gotten a lot of insight too. Some of these didn't come as a big surprise to us, but other ones maybe so. The first one was that DoD sites are highly variable, and so from an implementation perspective, we were able to move pretty quickly on our own network in DoDNet, but progress at the Pentagon has taken significantly longer, both because of the complexity of the local network, but also because cleanup efforts of previous network migrations haven't always been carried out to the fullest extent. So we've kind of been using this as an opportunity to clean up some of that tech debt. The technology deployment is really the easy part here. So it's taken us time to deploy these components and do the initial configuration and work through DoD's bureaucratic processes to get authority to operate. But the hard part really begins now, which is to write policies that make use of these components, to work with programs and authorizing officials on determining what level of conditional access, for example, is appropriate for any particular application in the threat model they're exposed to. And so we kind of see the evolution of the culture, policies, and procedures as long-term challenges for us. And we're engaged with our risk management executive to distill some of the lessons learned from our prototype into things that can then flow into STIGs and into SRGs in a technology independent manner. So we're not looking to get a mandate for our application security stack, for example, but it might make sense for us to mandate that everybody should implement lateral movement restrictions in their application architecture. And so that effort too will take a significant amount of time for us to work out. Interoperability with other ZT efforts is really, for the most part, non-existent. So as I mentioned, we've had a lot of good discussions with the services. And in some cases, there are fundamental IETF protocols that we can use to establish connectivity between different vendor solutions, especially in the routing use case, that's the case. But for the Sassy solution and Sassy solutions in general, almost all of the protocols used by vendors today are proprietary. So if we have a breadth of different solutions deployed across DoD, that potentially will limit how we can interact as a department and how we can support the warfighter. And so it's important for all of us to kind of get on the same page, go back to the vendor community, and ask them to work on at least a rudimentary level of interoperability between their solutions so we don't leave anyone behind and in need of information that they can't get to. Mobile user deployments have been kind of challenging for us, and so this is really more of a DoD problem, I think, than a vendor problem. But because of DoD's reliance on certificates for user authentication and derived credentials specifically on mobile devices, that's really a use case that many of our vendors have never dealt with before. And so if you pair that with the idiosyncrasies of mobile operating systems and how certificates can be accessed, that's presented some interesting usability challenges. So we've been able to support mobile platforms for both Android and iOS. But in some cases, currently, that requires more friction than we would maybe like to expose our users to, and so we're currently working on mitigating some of those impacts. And then lastly, the lack of DoD-wide endpoint credentialing solutions is kind of challenging for us because there's not a single DoD PKI provided profile for endpoint credentialing. It's difficult for us to provide the same rigor to authenticate user endpoints and devices more generally. And so every service has kind of invested in its own solution to that. Some of them don't implement any certificate-based solutions, but we think it would go a great way and make the whole environment more interoperable if we had a single profile at the DoD level to implement cryptographic validation of DoD-issued endpoints. From a roadmap perspective, for us, the next steps are fairly straightforward. They're specifically to improve the site designs for our fourth estate and current JRSS users that want to migrate to Thunderdome, as well as to work on the development of conditional access policies and application security stack deployments for these DISA and 4E&O customers that we're supporting as part of the DoDNet deployment. Expansion on Nipper and SIPRnet. Didn't really talk a lot about SIPRnet here, and it's kind of challenging in a public forum. But we're looking to reuse some of the lessons learned from our Nipper pilot, tailor them to the threat environment and the kind of idiosyncrasies of the SIPR environment, and then bring them to bear there for microsegmentation and conditional access. And there are some other use cases that we've got in mind that require more policy work before we can move out on them. And then lastly, I had touched on this earlier, we are in pursuit of cloud access point equivalence for remote users, so we can provide access to IL4 and 5 resources that are not currently sitting behind the cloud access points using our Sassy solution for equivalent security to what the CAP security stacks provide today. In terms of additional ZT-related DISA efforts, we have a couple of them listed here that are going to contribute to the more holistic implementation of a zero-trust architecture for the enterprise. And for some of these, we have current pilots ongoing. For other ones, we're kind of in selection of suitable solutions right now, and we'll probably undertake pilots later this year or next year. But roughly, next-gen antivirus, EDR, and XDR are pretty high on top of our list, and we currently have a pilot at DISA for that. For unified endpoint management, we currently have an effort that our Emerging Technologies Directorate is undertaking. We have an effort to provide automated security validation, which is going to contribute to the validation of the effectiveness of our sensing and security infrastructure. And that is currently ongoing out of my directorate. For security and security orchestration and automated response, the SOAR capability I talked about earlier, we currently have an ongoing effort in my directorate. One of the future roadmap items that we're kind of in the process of looking more in more detail at is advanced application programming interface security, API security. So east-west inspection of traffic is great. Gives us insight into what's going on between different components of an application, but it doesn't necessarily provide visibility into how an application interacts with external services using APIs, and so we thought it was important to get that visibility as well, and we're going to be undertaking a pilot in pursuit of that. Virtual desktop infrastructure is interesting for us both in terms of providing a consistent consistent desktop experience to our users, but also to limit how we're exposing data to less managed devices, or maybe devices that have a less rigorous security posture. And there's currently a pilot undertaken in our endpoint management directorate. Advanced microsegmentation and flow mapping we thought was really interesting, and we're not currently undertaking a pilot there, so if you have a solution that might contribute to that, come and see me. But the basic idea is to establish exactly what endpoints are available on our network, how they're communicating, and to identify both rogue devices on our network and rogue communication patterns that maybe we weren't aware of. And then lastly here, data labeling, tagging, Drm and Dlp. I touched on it's a really complex problem. I think it takes a lot of collaboration across the DoD and from the CDAO to get after this, but we're all keenly aware, I think, that this is a problem that needs to be solved. And so we're going to implement some more automated solutions initially, chiefly Microsoft Advanced Information Protection to perform some automated labeling. But we need a more holistic solution to go after different information silos, and we'll be looking at different solutions to that problem later on in the year. All right, and with that, I'll turn it over to you for any questions. And I don't know if we've got a microphone for the audience here. Yeah, he's coming with a microphone, sorry.
There you go, sir.
Hello, Monty Ansel, MPO Digital. My question was, how far along are you in the pilot for the advanced API security?
Yeah, so we haven't actually started that pilot yet. We're we have a technology in mind that we want to deploy, but we haven't deployed it yet. Yeah.
Can I reach out to you after this?
Yes, you can.
I want to.
There you go.
No, it's fine.
You mentioned an award was done on OTA, but then you're doing pilots. Would the OTA be responsible for doing those evaluations?
So these efforts, for the most part, aren't part of Thunderdome. They're individual pilot activities that we or other parts of DISA are undertaking. I think it's important to understand that Thunderdome can only go after a certain set of capabilities at a time. We have different pieces of the agency working on different problems, right? We've got an organization only dedicated to delivering endpoint solutions, for example. And kind of the technologies that are going to make up DISA's roadmap of zero trust technologies more holistically is spread across the agency. We're really just a part of that. And there's coordination across the agency to make sure that all of those are being deployed in lockstep and that everybody's aware of what needs to be accomplished. But in many cases, those won't be part of our OTA, so we wouldn't be awarding those as part of Thunderdome.
How much resiliency are you building into the pilot?
So that's kind of a difficult question to answer. The Sassy solution is a software as a service offering. So you get the resiliency of two individual portal implementations in US East and West, and the resilience built into the AWS cloud services are underpinning that. For the remainder, it kind of depends on the site architecture, really. Our standard deployment pattern is to field at least 2 devices to each site and peer them individually with 2 separate JPE connections, so that we have both JPE redundancy and device redundancy in an active-passive fashion. The deployment really depends on the requirements of the site, right? Both in terms of the size of the device we're deploying and the resilience we need to build in. So there's no reason why you couldn't deploy more devices if the mission requires. But two is kind of the minimum recommendation we would make. Don't rely on a single device, please.
So the DRM capability that you talked about, will it rely on the data labeling, or could it be based on policy actions? Or, because I could imagine a scenario where you might say, I'd like to encrypt this traffic if someone downloads it to an unmanaged device or something like that.
Yeah, I think the answer is both. So in many cases, we will want to restrict what you can exfiltrate from the device. And so tagging and labeling are kind of prerequisites for that. But in other cases, I think just being able to ensure that data can only be accessed through a certain path or is encrypted when it leaves our network will be sufficient. And so I think the answer will be both. All right. If there are no more questions, if you didn't want to ask a question out loud, feel free to come up. I'll be here for a couple of minutes. And if you don't have any more questions, thank you for attending. And my contact information is available, so if you think of questions later on, please feel free to reach out to us, and I'll make sure they're addressed. Thank you.